we're going to talk about the second derivative test, which is a different way of identifying relative maxes and mins using the second derivative instead of the first derivative. So what we've learned so far is that the first derivative, f prime of x, if you set it equal to 0 or say that it's undefined and solve for x values, those are called critical numbers, those x values. So relative mins and maxes might happen at those critical values, or those critical values might just not really mean anything. So we've done the first derivative test in a previous chapter. The second derivative test, which is setting the second derivative equal to 0 and saying the second derivative is undefined and then solving for those x values, that can also help us find relative maxes and mins. So basically we're given a different set of information but asked to find the same thing. So first off, what we need is to figure out what are the critical numbers. So critical numbers happen when f prime of x equals 0 or is undefined at x equals a. That's where f of x possibly has relative maxes or mins. Okay, those are the only possible points that it can happen at, other than endpoints. Okay. Then we have three different options of things that could end up happening. If your second derivative is negative at that certain x value, so x equals a, that was one of the critical numbers that we found. If we find that the second derivative is less than 0 or negative at that x value, then we know that f of x is concave down. So that's what we know so far. We've done that with second derivatives already. So if f of x is concave down, that means our picture is going to look something like this, more or less. So a would be this spot right here. This would be a graph of f of x, so our original function. Okay, our original function would be concave down, which means that at x equals a, this point right here would be a relative maximum. Okay. The next option, number 2, is basically the same thing with all of the opposite signs. So if our second derivative at a certain x value is positive, greater than 0, then we know that f of x is concave up. So let's draw a little picture for f of x. This point right here would be at x equals a. And this is concave up because the cup or the bowl is pointing upward. Cave is pointing up. We know that f of x is a relative minimum, has a relative minimum at x equals a, because that's the only spot where we can actually have a min or a max, and it's got to be a critical number. Okay, number 3, if f double prime of a equals 0 or is undefined. So that's the third option. So we've got f double prime of a is negative, f double prime of a is positive, and then these are the other options if second derivative is 0 or second derivative is undefined. What we've been doing with this so far, where f double prime of a is 0 or undefined, that's where we have possible points of inflection. So that's where this last sentence comes from. Usually there's going to be a point of inflection at x equals a. We know that doesn't always happen, okay, because sometimes the sign for f double prime does not switch at whatever that a value is. Okay, but usually there's going to be a point of inflection, and because we can't really tell, we say that we can have no conclusion about relative extrema, and relative extrema means relative mins and maxes. Okay, so we don't know if the picture looks something like this, where we have concave down and then concave up, and this is definitely not a maximum or minimum. This would be like an f of x graph. Other options, we could have like an x cubed function, but a portion of that could look like this. So the second derivative is, oh, that still wouldn't work. I know there's other options where if the second derivative equals 0 or is undefined, it's not a point of inflection, but it could be a relative max or a min. So we don't know one way or the other. So let's do a couple problems that go along with this. We're going to use the second derivative test, which is what we just talked about, to locate and classify all x values of relative extrema for the function. So first off, we need to find where does f prime of x equal 0 and where is f prime of x undefined. So we're going to find f prime of x by taking our first derivative. That is 4x cubed minus 12x squared. Okay. This can never be undefined because no matter what you plug in for x, there's no denominator that equals 0. Basically, your domain is all real numbers. So we set this equal to 0 and then factor and solve for x. So we get 4x squared times x minus 3 equals 0. Second factor means x has to equal 3. And first factor, x is going to equal positive or negative square root of 0, which means x equals 0. Okay. These guys right here are called critical numbers because they came from our first derivative. Critical numbers or critical values, either one, came from the first derivative. So these guys are going to be potential mins and maxes. Okay, let's find the second derivative. So come back up to the first derivative and take the derivative of that. So 4x cubed, the derivative is 12x squared. Negative 12x squared, derivative is negative 24 x. Okay. Again, this is a polynomial, so we know that it is defined everywhere. So we just set it equal to 0, factor, and solve for x values. 12x times x minus 2 equals 0. So x equals 0 or x equals positive 2. Since these x values came from the second derivative equaling 0, these are our potential points of inflection. We don't know yet whether they are points of inflection or not because we don't know if the sign of f double prime of x is going to switch at those two x values. Just like we do not currently know whether the sign of f prime of x switches at x equals 0 or x equals 3. All right, so we found all of our important numbers. Let's use 0 and 2 on our second derivative chart. So we're going to make a sign chart with a second derivative. F double prime of x. Our two potential points of inflection are 0 and 2, so those are the only two numbers that actually get marks on here. We need f double prime of, let's pick negative 1. F double prime of 1 is between 0 and 2. And how about f double prime of 3? Okay. All we care about for this sign chart is whether the second derivative is positive or negative at those x values. So let's plug in, let's see, negative 1. Let's plug it into this factored form. So we've got positive for 12. We've got negative for x. And then negative 1 minus 2 is negative 3, so that's negative. Multiplying positive times negative, we get a positive number. So our second derivative is positive on the interval from negative infinity to 0. Let's check f double prime of 1. We're going to plug in here again. So 12 is always positive. Plugging in positive 1, x is positive. And inside the parentheses, 1 minus 2 is negative. Positive, positive, negative multiplied is negative. And now let's check 2. F double prime of 3. Plug in a 3. 12 is always positive. 3 is positive. And inside the parentheses, 3 minus 2 is 1, which is positive. Triple positive multiplied is positive. So we know from our second derivative that the second derivative is positive and then negative and then positive again. So x equals 0 and x equals 2 are both points of inflection because the sign changes at each of those x values. But that's not what we're asked to find. We're asked to find relative extrema. So what we need for that is our second derivative test. Okay. So we need the a values that make f prime of x equal 0 or f prime of x undefined. And we want to know if the second derivative at those x values, the critical numbers, are negative or positive or equal 0 or undefined. Okay, so second derivative, negative, positive, 0 or undefined at our critical numbers. Okay. Our critical numbers are x equals 0 and x equals 3. So at x equals 0, which is our first critical number, well, our second derivative equals 0. Our second derivative also equals 0 when x equals 2. So at x equals 0, f double prime of x equals 0. Another way to write that would be since f double prime of 0 equals 0, right? X value and then second derivative value, x second derivative. Okay. This falls into the category of number 3, and number 3 says we can make no conclusions about relative maxes and mins. We can make no conclusions about relative extrema at x equals 0. Okay, we do have another option. Our other option is x equals 3, right? The potential mins and maxes happen at these two critical numbers. So let's try x equals 3. That fits in right here. So since f double prime of 3 is positive, so it's greater than 0, that means our graph of f of x is concave up. F of x is concave up. At x equals 3. Okay. So concave up looks like this. So 3 is going to be the x value of this spot right here. So that means that at x equals 3, f of x has a relative, it's at the bottom, so it's a minimum. So f of x has a relative minimum at x equals 3. Okay, take a look at what this graph looks like in your calculator, and hopefully you'll see what I mean. Okay, so let's set y equals x to the 4th minus 4x cubed plus 2. And let's take a look at the graph. Okay, obviously we don't get all the information, so I'm going to hit zoom 6. Hopefully that'll get it all. Nope, still didn't get it all. But we can see that at x equals 0, we have a point of inflection. We switch from concave up to concave down. However, it's not a max or a min. So that's what this was all about. Right here, point of inflection, but no max or min. And then we know that at the bottom of the graph down here, there's going to be a minimum. 1, 2, 3 is going to be that x value. You could zoom out and see more. Okay, number 2. F of theta equals 2 cosine of theta minus theta on the interval 0 to 2 pi. Okay, so theta has to be between those two x values. That interval is so important because that means that our sine chart has a beginning point of 0 and an ending point of 2 pi. I'm going to make them open circles because there's no equals bars under either of those. Okay, so that means we don't have to pay attention to the endpoints, but we can't pick numbers that are less than 0 or greater than 2 pi. Okay, let's find f prime of theta. We know we need to find critical numbers. Okay, derivative of cosine of theta is going to be negative sine of theta, but we've got a 2, so it's negative 2 sine theta. Okay, derivative of negative 1 theta is just negative 1. Okay. Sine of theta is defined everywhere between 0 and 2 pi. There's no undefined signs. So let's set this guy equal to 0 and solve for sine of theta. So I've got negative 2 sine of theta equals 1. So sine of theta equals negative 1/2. Okay, sine of theta equals negative 1/2 at theta equals 7 pi over 6 and at 11 pi over 6. Okay, so these guys right here are our critical numbers, which means they're the potential maxes and mins. Alrighty. Let's find our second derivative. So f double prime of theta equals, take a derivative of this guy right here. So negative 2 times cosine of theta. And the derivative of 1 is just 0, so it's gone. Set cosine theta equal to 0. And see what we get. Divide both sides by negative 2, which means cosine of theta equals 0. And cosine equals 0 in between theta equals 0 and 2 pi. Cosine equals 0 at where? Look on the graph. Cosine goes like this. This is pi. This is 2 pi. So this is pi over 2 and 3 pi over 2. Okay, so theta's got to equal pi over 2 and 3 pi over 2. Okay, let's toss those over here. Pi over 2 and 3 pi over 2. Okay, 7 pi over 6. 7/6 is between pi and 3 pi over 2, so it's in this middle area right here. So we want f double prime of 7 pi over 6. And 11 pi over 6 is in between 3 pi over 2 and 2 pi, so we need f double prime of 11 pi over 6. We don't even need to know what this value is over here. We just need to know in between. Okay? And honestly, you could just plug these values in here and figure out what the signs for cosine of theta are, cosine of 7 pi over 6, and so on. Let's see. If we plug in 7 pi over 6, negative 2 times cosine of theta, so that's going to be negative times negative, which is positive. This one right here, negative 2 times cosine of 11 pi over 6 is going to be positive, so we end up with a negative value there. We don't care about this because none of our critical numbers are in that spot. Okay. So since f double prime of 7 pi over 6 is greater than 0 because it's positive, f of x is concave up at x or theta equals 7 pi over 6. So we know that f of theta has a relative min at 7 pi over 6. And this should be theta. All right, next one, since f double prime of 11 pi over 6 is less than 0, it's negative from our chart, we know that f of theta is concave, it's negative, so concave down at theta equals 11 pi over 6. So f of theta has a relative maximum at 11 pi over 6. Okay, if you want to draw the pictures every time, concave up looks like this, so there's got to be a minimum. Concave down looks like this, so it's going to be a maximum.